Good morning to all. Myself Dr. K. Manoharan, Associate Professor, Department of Biomedical Engineering. So today class we are going to discuss about flag registers. Look at this. This is the format for a flag register of 8086. So some of the bits are not implemented. Look at this. This empty bits are not implemented. We have the remaining bits. This will be implemented. This is carry flag, parity flag, auxiliary flag, zero flag, sign flag, trap flag. That is interrupt flag, direction flag and overflow flag. We can see each one detailedly. Look at this first one, CF. This is carry flag. So these flags sets whenever there is an carry. So carry comes out from an MSB bit. Whenever you are adding an 8-bit number with another 8-bit number, the 9th bit will be called as a carry flag. So the carry comes out from the MSB bit, that will be called as a carry flags. Look at this second one, parity flag. So whenever we are transmitting some data, so we use parity for an error detection. So not error correction, this will be used only for error detection. So we use two type of parities, one is odd parities and another one is even parities. So here after completing that particular operation, whether the results, that is the result means that accumulator content contains how many number of ones, that is odd number of ones or even number of ones, that will be predicted by using this parity flag. Look at this. So it takes the ones, whenever this will be an even number of ones, it will be set. Whenever odd number of ones, it will be becomes a 0. Whether set or reset depends on odd number of ones or even number of ones. Next, look at this. This is auxiliary flag. So whenever you are performing a BCD operations, there is a binary coded decimal, we need this auxiliary flag. So if you take an 8-bit, that will be called as a byte. If you take an half of that byte, so this is only a 4-bit, that will be called as nibble. So whenever you are performing a nibble addition, we need to have this auxiliary flags. So whenever there is a carry from a lower nibble to higher nibble, that is we take it as a D3 bit. So D3 to D4, whenever we have a carry, so that carry will be predicted by this auxiliary flags. So if you take this lower nibble to higher nibble, there is a carry flow, so that will be predicted with this auxiliary flag. So this will be most useful whenever you are performing a BCD operations. BCD arithmetic operation, we use this auxiliary flags. Look at this next one, this is zero flag. So zero flag, that will be used to predict whether the result is 0 or non-zero, not other than that. So very simple. So after completing that particular operation, the result content, that is accumulator content, whether it is a 0 or non-zero. So whether it will be a positive number, negative number, nothing like that. It will be considered only a whether it is a 0 or non-zero results. So whenever the result is 0, the 0 flag sets. Whenever non-zero result, the 0 flag becomes 0. That is, it won't set. Look at this next one. This is a sign flag. So this is used for a sign detection. So normally for a sign detection, we use an MSB bit as a sign flag. So for a sign flag, whenever it will be that MSB bit is 1, it indicates a negative number. Whenever that MSB bit is 0, it indicates positive number. So whether the result is positive or negative, that will be predicted by using the sign flags. Look at this next one. This is trap flag. So this will be used for a single step operation, that is debugging of a codes. Whenever you have a codes, whenever you are executing, you are getting some results, but it is not correct. So how to check it? We can use this single step operation. So what happens here? So it executes step by step and it shows the results in the registers. So based on that results, we can verify whether the actual operation is performed or whether the modification is needed. So after executing individual each instruction, it shows all the register. So step by step we can execute. So we can easily debug the entire codes and find the bugs or mistakes in that particular code. So this will be useful for developing a codes. Next one, that is IF. This is interrupt flag. So whenever we use this 8086, so whether to enable an external interrupt or disable the internal interrupt, so we can use this IF. So what is first interrupt? Whenever you are performing some operation, So if we have some other important task than that normal operation, we need to give that priority to that particular task. We need to complete the task, again come for the main work. Same thing that will be happens in the microprocessor also. So for example, if your normal task will be done, whenever fire detected, we need to turn on a buzzer or a siren means. So we can use this fire sensor, fire detection sensor that will be connected to an interrupt flag. So interrupt register. So once this interrupt is detected, the microprocessor stops the current execution and puts the values in the stack and then identify which interrupt is occurred. So the corresponding siren on program that will be executed after completing that siren program. So that is a siren program. It comes for the main loop. So what is the need for interrupt means? So whenever we use a normal system without interrupt means the processor time is wasted. For example, if we use a fire sensor, we need to monitor whether there is a fire detector like that. So what happens, the processor time is entirely wasted. To avoid that only we use this interrupt concept. So once interrupt concept used, no need to check whether the signal is come or not. So very simple, we can use execute the normal programs. Whenever interrupt occurs, this will be indicated to the microprocessor. So some application we use interrupt, some application we won't use interrupt. Any application if we are not going to use an interrupt, we can disable it. So if you need to use an interrupt, so automatically we can enable it. So for that only we use this IFs. See, processor time is very much saved because we have a 4 interrupt. Each time if we check it, so frequently means the processor time is unnecessarily wasting. So this will be avoided using this interrupt flags. Look at this next one, direction flag. Whenever you are performing a string operation, so string means it's a group of characters. So whatever you are performing operation, so it will be applicable for all characters. String copy, string concatenate or string reverse, any operation. So all the characters will be performed on that particular operation. So whenever you are accessing the string, so the next character should be incremented. So whether increment or decrement, how it decrements means, so we have a group of characters string, so it can be indicated with the starting address or ending string. So for example, if we have an SNS college, so we can indicate with the starting of S or ending with an E letter. Okay, so that string can be indicated both starting address or ending address. So whenever you are indicate with the starting address, we need to increment to get a next characters. Whenever you point with an ending character, for a next character we need to decrement. So whether increment or decrement, that will be decided by this direction flag. So direction means which direction. So it indicates whether to increment or decrements. Again, whenever you use this byte concept, we need to increment 1 time. Whenever you use a word, we need to increment 2 times. So increment or decrement decided by the direction flag. 1 time or 2 times, that will be decided by byte or word. Look at this next one. This is overflow flag. Whenever there is an overflow, that means, for example, if you are adding 2 negative numbers, that is 2 negative numbers, the result should be negative. But what happens that MSB bit, that sign bit, sometimes affected by the data bits, because microprocessor don't know this MSB bit as a sign bit. It considered as a normal bit, it performs that operation. So whenever sign bit is affected, that will be detected by this overflow flag. Whenever, look at this, whenever you are adding 2 negative numbers, if it produces positive results, or whenever you are performing 2 positive results, it gives a negative numbers like that. So how it will be predicted means, so if you take a data bits, so D0 to D15 is a data bits, so there is a carry consider, so D14 to D15 and then D15 to D16. So there is a carry in for that is D14 to D15 and D15 to D16. So both have carry means there is a no overflow, or when there is a no carry in both cases, that is a D14 to D15 and D15 to D16. So this also there is no overflow. But in vice versa, that means there is a carry in from D14 to D15 and there is a no carry out from D15 to D16. This is the overflow. Similarly, there is a carry in from D14 to D15 and there is a no carry out from a D15 to D16. There is in 2 cases. There is a carry in and no carry out, or no carry and no carry but there is a carry out. So these cases it affects the sign flag. So these sign flag effect will be predicted by using this overflow flag. Thank you.